Today we're going to learn about the quadratic formula. So let us solve the equation. X squared minus 6x plus 1 equals 0. That means find all numbers x that make this equation true. So for this question, we are using completing the square to solve it. So question asks us to use completing the square. So we will work on x squared minus 6x. So our formula will be ax squared plus bx plus b over 2 squared minus b over 2 squared plus c. So now plus b is negative 6 over 2. So a is 1, b is negative 6, c is 1. Then square minus negative 6 over 2 square plus 1 equals 0. So now I will take this, the square part, inside the bracket and put inside the bracket negative 3 square. And then I don't want this middle. I will take this all. Now let negative 8 to the right. X minus 3 square equal 8. Then x minus 3 is equal to 8. Then we have plus minus 8. So x is 3 go there, become plus 3 plus minus 8. So we have two different value. X is 3 plus 8. X is 3 minus 8. So whenever we take square root of both sides in an equation, we must include plus or minus because both a positive and a negative number squared give the same result. So now you can also simplify the set 8 to simplest radical form, which is x equal to 3. Okay, set x is set 4 times 2. Set 4 times set 2, which is 2 set 2. Okay, so plus 2 set 2. The other one is 3 minus 2 set 2. So by completing the square, we found the roots. And they are already now in simplest radical form. The numbers inside the root cannot be simplified further. Alright, so we just solved one quadratic by completing the square. If we did the same steps, but with letters instead of numbers, for the general quadratic ax squared plus bx plus c equals 0. So this is our general equation. Then this is our formula. Okay, so a is coefficient of x squared, b is coefficient of x, c is constant term, b squared minus 4ac is called as the discriminant. Okay, so this formula tells us the solutions for any quadratic equation as long as we can identify a, b, and c. It's like a calculator in a formula form. So in the next exercise, we'll use this quadratic formula. Okay, so from exercise 1, we try to use the quadratic formula and give answer in simplest radical form. So this x squared minus 6x plus 1 equals 0. We need to write down in this form. And if you compare, we know that a is 1, b is negative 6, c is 1. So then we put it inside the formula. So negative b is negative 6 plus minus z, negative 6 square minus 4, 1 times 1 over 2a, a is 1. Okay, then we can simplify it like negative, negative, positive, plus minus 6 squared, 36 minus 4 over 2. Okay, then we also know that we can simplify. Here become x equal 6 plus 32 plus minus 32 over 2. And the 32 actually, we can change it in simple radical form, which is 16 times 2. So set 16 times set 2 is 4 times set 2. Okay, so 6 plus minus 4 set 2 over 2. And then we can divide both, become 6 divide 2. Like we factor out first, 2, 3 plus minus 2 set 2. And then we can divide the top and bottom, like 2 divide 2 is 1. So 3 plus minus 2 set 2. So x is 3 plus minus 2 set 2, same with the question 1 that we use, completing the square. Okay, next we move on to number 3. So which of the following represent the solution? So first we will straight away use our quadratic formula. So quadratic formula says that we need to know about our ABC. B is negative 10, C is 20. So now I already identify my ABC after comparing with the original equation, ax squared plus bx plus c. So I straight away put inside the formula, negative b plus minus b squared minus 4ac over 2a. So negative b is negative 10 plus minus negative 10 squared minus 4 a c. So a is 1, c is 20, plus, and then solve inside the set. It will become 100 minus 80 over 2. So which is also 10 plus minus set 20 over 2. Okay, so if you remember, set 20 is, you can make it smaller by set 4 times 5. So set 4 times set 5 to set 5. Okay, so here you will get 10 plus minus 2 set 5 over 2. Okay, then factor out 2. So 2 out, 5 plus minus set 5. So remember, when you take out, you need to make sure when you multiply again, you get the same factor. So 2 divide 2 is 5 plus minus set 5. So answer should be option 4. So the solution set is 5 plus set 5 and x equal to 5 minus set 5. So answer is in AC method, A times C. AC is 2 times negative 6, which is negative 12. So factor to get negative 12 is, we have 1 times negative 12, 2 times 6, 12. Okay, so we need to make sure our sum to get B is 11. Okay, so I can see that if I put minus 1 plus 12, I will get 11. Okay, so I will take this factor. So as being 2x squared plus 11x minus 6 equals 0, I can change it to 2x squared plus 12x minus x minus 6 equals 0. Okay, next I need to split it so that I can factor it out. So I can put 2x squared minus x plus 12x minus 6 equals 0. So this one I can factor something out. This one I can factor 1 out, or x out. So x 2x minus 1 plus, I take out 2, so if I take out 6, I can have 2x minus 1 equals 0. So you can see that in the bracket, you have the same factor. So you can copy only one time, 2x minus 1, x plus 6 equals 0. So this will be your factor. So from here, you can make it 2x minus 1 equals 0, x plus 6 equals 0, x is negative 6, x is 1 over 2. So you have two factor half and half or 6. Or you can actually use quadratic formula. This 11 plus minus 11 square minus 4 times 2, c is negative 6 over 2 times 2. Okay, so from here, you will have the set below, you can solve it, become 169 over 4. Okay, then you know that you can also 169 have a perfect square, which is negative 11 plus minus 13 over 4. So from here, you can split it into 2, which negative 11, x is negative 11, plus 13 over 4, x is negative 11 minus 13 over 4. Okay, so from here, you will get negative 6 or half. We need to use our quadratic formula. So A is 3, B is 5, C is 2. So we'll substitute all my A, B, C to the equation. So it will be negative B plus minus z b square minus 4ac over 2a. So negative 5 plus minus 5 square minus 4, 3, 2 over 2 times 3. So from here, you will get x is actually minus 5 plus minus 1 over 6. So now you can, because set 1 here, set 1 is 1. So we will just remain it to 1. And then you have two value, which is x is minus 5 plus 1 over 6, which is 2 minus 2 over 3. X is minus 5 minus 1 over 6, which is negative 1. So both are rational numbers. For B, so A is 1, B is negative 8, C is 13. I put inside negative 8 plus minus z, negative 8 square minus 4 times 1, 13 over 2 times 1. So after I solve it, it becomes plus 8 plus minus z, 12 over 2. Okay, so set 12, I can make it smaller too. Set 12 is actually 4 times 3, which is set 4 times set 3. It is 2 set 3. So here 2 set 3 over 2. Okay, then both term on top, we can, like top one, we can factor out. So 2, 4 plus minus 3 over 2. And then you can divide 2 with 2. And your answer should be 4 plus minus 3. So first x1 is 4 plus 3. x2 is 4 minus 3. Okay, next we move on to C. So C, A is 2, B is negative 2, C is negative 5. So again, put inside negative 2 plus minus z, negative 2 square minus 4, 2 times negative 5 over 2 times 2. So from here, you will get x is, here become plus minus z 44 over 4. So z 44 is set 11 times 4, which is set 11 times set 4. So you have 2 set 11. Okay. So here change to plus minus 2 set 11 over 4. You can factor out 2. So it is 1 plus minus set 11 over 4. So 2 divide 4 is 1 over 2. So 1 plus minus set 11 over 2. Okay, so first solution is x1 is 1 plus set 11 over 2. X2 is 1 minus set 11 over 2. Then for D. Okay, for D, A is 5, B is 8, C is negative 4. So put inside the formula 8 square minus 4, 5 minus 4 over 2 times 5. Okay, then you solve. Top become minus 8 plus minus set 144 over 10. Okay, set 144 is plus minus 12 over 10. So x1 is negative 8 plus 12 over 10, which is 4 over 10. Make it smaller, 2 over 5. x2 is negative 8 minus 12 over 10, which is negative 20 over 10. It is negative 2. So you have two different values here. So remember that when the discriminant b square minus discriminant is this. Discriminant is b square minus 4ac is a perfect square. We get nice rational answer like this. Negative 2, 2 over 5. But when the discriminant is not a perfect square, we keep the square root and write the answer like 4 plus minus set 3. So the quadratic formula works for all of them as long as we go slowly and simplify carefully.